where the database writes the actual rows. Yeah. So data block, it contains one or more data rows from the same table. As we know, Teradata doesn't share the data blocks with other tables, right? So the system shows the data blocks in segments. So which is again grouped into cylinders. Okay, the segments are grouped into cylinders. So you can set this data block size in two ways. The first one is through the table creation DDL from the SQL. Okay. And the other one is setting them globally using the DBS control. Okay. And if there is a conflict between the data block size which you give to the DDL and the global DBS control parameter, so whatever you give in the table creation will override the default value. Okay.
Okay.
Yeah. So it's similar to creating a table. You just need to add the data block size. Just a keyword, data block size equal to how many data blocks you need to have. So 1024 or depends, right? And Teradata recommends that if most of the queries to the table access a single row of data, means number of queries accessing a single row of data in the storage, then you need to give a smaller data blocks, right? Because if you give a bigger data block, then it need to go and search the rows, right? So if you give a smaller data block size, then it will be replicated, and searching and finding out the row will be easier. As we saw earlier, the binary search will happen to find the row and all, right? So when most of the queries of the table access a single row, then you should give the data blocks to be smaller one. So in the other case, so most of the queries access the entire table data. So in that case, you can define a larger data block, because anyway all the rows has to be read, right? So if you have a bigger data block, it will be useful in the performance.
Okay.
Yeah. So one second. Okay. So as we know, we can set it in the DBC control parameter also. So for doing that, you need to change the parameter settings. Okay. So the minimum data block size after 13.10 version of Teradata is 42 sectors. So the minimum data block size accepted for this create or alter table statement is 21248 bytes. That comes around 41.5 sectors. Okay. So you can't define below this. Okay.
Okay.
And the maximum size is 2047 sectors. That comes around 1048064 bytes. And we can convert this, I think, 104 KB. It will come around, I think, right? So 725 now.
I think 10 MB.
1048.
No, 1 point. 1.04 MB, something like that.
Yes, yeah, around 1 MB. So this is the maximum data block size you can have, and you can change these parameters through utility called DBS control. So earlier we saw ferret, right? So similarly, we have another utility. Okay, so these are the steps. Okay, first you need to open this DBS control. That's the utility. So let's open it.
Okay.
So we are connected to the DBS control now, and then you need to give display file system, which will give you the configuration of file system. Okay. Okay, so these are the DBS control parameter for file system. Okay. Okay, so you can have different different settings there. So in this permanent DB size, you can see, right? So this is the having the configuration of setting sectors is the blocks, right? So if you want to change it, the default one, so now it is 2048. If I want to change it to 2024, right? So 2047 is the max block size, right? So currently it is in max block size setting. Got that, right? So I'm going to reduce it to 1024. So in that case, what you need to give is it is in the parameter 3, right?
Okay.
So if you see, it's in the parameter 3, correct? So I'm gonna give file sys 3 equal to 1024. Modify, I forgot this modify. Sys. Okay, now
You are giving that order as a number.
Yeah, order as a number. Yes. So this file sys 3 is the one which we saw earlier.
It is in third place.
Third places. Perm DB size. You can see it here. Permanent
Okay,
DB
that
size.
is okay. That is only you are changing now.
Yes, that is what I'm changing. So currently it is in 2047. Now I'm reducing it to 1024 sectors. Okay. You see here it has been modified from 2047 to 1024.
Okay.
Okay. Now you need to write it. Right. Okay. Now, if you see here, the DBS control parameter is updated. Okay. Now, if you give this file check command, display file system. Now it's changed to 1024 sectors, right?
Okay.
So this is how we change or maintain these sectors, the block sizes. Okay.
Okay.
And this is how you change the DBC database parameters. Okay. There are various parameters through which through this DBS control, you can change those. Okay. Sometimes
Okay.
Teradata may recommend you to change. So in that case, you can come here and check which parameter and you can change. Okay. So let me exit. Okay. This is about the block size. And then we asked about the TVS. So TVS is nothing but it's a added feature actually. It won't come with all the databases. So it's almost an additional feature. Okay. So if we want, you can buy it. So what this TVS, which is Teradata Virtual Storage, it does is like it allocates, it keeps tracks of the data stored in the physical drives. Okay. So it maintains statistics. So for the data temperature, like we have different data storage, like hot data we can say, which is accessed frequently, and cold data, which are archival data, which won't be accessed frequently, right? So it keeps statistics of this temperature of the data. And what it will do, it will automatically migrate the data, right? The cold data to the slower drives, and it will migrate the hard data to the faster physical drives. Okay. So what this will do, it will reduce the IO. Also, it will reduce the total elapsed time for the query, right? So
Okay.
this is the work of this virtual storage. Okay. And
Okay, that means it will move the
sectors in the,
files.
yeah, it is stored. It will move the data stored in the drives. That is, it will move the sectors from one drive to another. Okay. So without degrading the performance of the system, or without it, we don't feel the the movement also. Okay.
Okay. Okay.
So why this actually comes up is like we can have the mixed storage technologies, like different types of drives. You can have different speeds, different capacities, right? We can have it in a parallel architecture. So this will ensure like most frequently accessed data is stored on the fastest drive. Right.
Okay.
So
Okay.
this is about this TVS. So again, in real world, like how it works is we have the SSD drives and HDD drives, right? Hard disk drive where it has a where it has a memory head and it reads from the CD kind of thing, right? So that will be obviously slower when compared to SSD, correct? So nowadays we have SSD. So even if you buy a new laptop, it comes with SSD and the HDD, right? So the fastest things we have like OS and all will have it in the SSD, and remaining data will have in the hard disk. So similar way, so in Teradata also we have mixed storage support. Like we have SSD and HDD. So depending on the data access, so the TVS will move the data to the fastest device. And also, if you want to expand the storage, so in that case, for doing so, you need to bring down the database actually, because you need to insert the drives, add it to the existing pool, and then you need to rebalance, right? Because the data will be returned to some drives only, right? So you need to rebalance the drives, and then you need to restart it. But when we have this TVS, it can be done without doing a restart. Okay, so that is on another advantage. Okay, so this is about the virtual storage. So let yeah, I'll show you the
Okay.
connect from the machine.
Okay, viewpoint.
Yeah, that's what I'm connecting from another machine.
Okay. Actually, how to configure viewpoint in the project which has started newly? You are checking something? Ashwin, can you hear me? Hello?
Right. Okay. So I was just telling, like, when you get the system, right? So first thing is the configuration. Initial configuration will be done by the Teradata. So not worry about
Okay.
that. They will hand over the viewpoint all configured with the systems. Okay. So in case if you want to go and check where to do it, you need to go to the settings and then monitored systems. So this will give you what are all the systems in your environment. Okay. And then in this you will go and enable the system. So if you give the details, TPT ID is your Teradata host name, right? ID, and then you will give this and you will enable it. Once you enable it, right, so you can access it from all the portlets. So portlets we call here, let me show you the different portlets. So suppose you want to add a new page. example, example. So go to add content, and then whatever portlet you want to add, like resource manager, you can have, and query monitor is a base, system health, productivity, metric heat map. So you can have all this. Let me add. Okay. So if you see this productivity, it will show you all the system health, how it is for past 24 hours. Okay. And if you come to this query monitor, it will give you all the details about what are the queries running. So from here, you can monitor the queries. And if you come to the heat map, it will give you the heat of the system. Like if you select system and then active system or total CPU SKU or AWT or CPU, you can select. You select CPU, average you can have. So in this average, so this is the date range from where okay. So you can change this to 80. So whatever greater than 85, I am marking it as red. So we can see the system is busy during 19th, that is 18th, 12 p.m., 12 a.m. and 29th. You can see it's around 12 a.m. again. Right. So with this, you can see like when is the system is busy, and if you see here, there is nothing running at this, like 32%. So maybe if a new jobs come, you can schedule it over here. Okay, this will help you in analyzing the system consumption. Okay, and this node resource, it will give you all the information about the node. You see, these are the nodes. So we have 6 live nodes and 3 standby nodes. Okay, so 9 nodes totally, and 2 outliner in the sense. So two nodes are having some issue. So in that case, remaining 1, 2, 3, 4. 4 will be there. 4 nodes will be there. Okay. So if there is outliner, then we need to check with the Teradata why it is showing an outliner. What is the issue with that? Okay.
Okay.
So this is about the nodes, and you want to see the workload stuff. So there is one more portlet called this is the workload monitor. So with this, you can see what are the different workloads. So we have 32 workloads here. So you can see here. So these are the different workload names. Okay. So whatever falls under this will come under this low. Okay, and then we have medium. So similarly, we have different workloads. Okay, so depending on the settings, each workload will be designed. Means each workload will run the query in it. So
okay, this workload is defined based on the CPU, how much it is consuming.
Yeah, mostly it will have the CPU or the time, how much time it is going to run.
Okay.
If it is going to run for more time, then it will be moved to long running one. Likewise, okay. So even this workload, initially it will be set up by Teradata. You can, if you want to analyze your workload, even Teradata will do that when you are in support. Okay, so you can have a call with them and you can ask them to check how your workload is doing. They will recommend if any changes has to be done in the workload. Right?
Okay.
Yeah. So this is the workload monitor.
This is similar to TDWM, Teradata Workload Manager.
Yeah, this is not the workload manager. I will show you the workload manager.
No, that's okay. Okay. I think
this workload designer is the workload manager now. Okay. So if we see, these are the rule sets we say. Okay. So you can see the last one running is the current one, which is active now. Okay. So if you want to go and change any other workloads, which is ready, right? So you can just go click and then activate. So that workload will come into picture. So whatever settings you have in that workload will be ruling the system.
Oh, okay, okay.
Okay. So and then you can create a new workload also by clicking on this. You can create a new rule set. You can specify the rules. You can define the throttles and all, right? So with that, you can have the new workload. So when initially the system is given, Teradata will have the basic workloads for you, and which you can modify in the future, depending upon the growth of the system. Okay. So if you see, these are the these are the throttles we say. Okay. So these are the different workloads depending on the profile names. We shortlist these throttles. Okay. Profiles we saw, right? We will create profiles depending on the application or business units, right? So this is how the throttle works. So okay. So this is the different workloads. So mostly it is designed on the timeshare model method. So which means like these queries will share the time within all the workloads. And if you want to have any exceptions, you can add it to the workloads, right? So this is for exception. Like you want to do all the query except for one user, then you can add it for that user.
Okay.
And this is the workload monitor we see. So this is about the workload. Anything else you want to see in the viewpoint?
Currently running queries, how much CPU it is consuming? If any queries running?
You can check from query monitor.
Okay.
You can see there is 27 active queries which is running, and you can see the CPU, how much request CPU it has submitted. Okay, and how much time. There are different columns. So here you can monitor spool space and product join index, temp space, which workload it is running currently. Right.
Okay.
So Mostly with the spool space,
We can see the
PGA and
query
CP.
also, no? We can see the query also, no? Here.
Yes, you just need to go and click, and then you have to see the overall, and then go to SQL.
Okay. SQL.
It will give you the query. If you want, you can click here and download it also. So it will get download. Similar way, you can navigate to explain, and then you can see like which what to say, which step it is currently, 4 out of 6, right? And then you can see what is happening, and then you
This
can,
will
if you want to
also
download
help
this.
in performance tuning, like which step
Yes,
is taking more time.
yes. So if you can see, the estimated time for this step is 1 hour 23 minutes, right? If you see the before steps and all completed within seconds, within milliseconds also I can say. So this is the step where it is taking more time. So what is happening? There is a all amp merge delete is happening on this table. So and it's a big table, so it's gonna take time. So likewise we can see how much time each step is taking.
Okay. But we cannot understand what data or what table or where exactly it is consuming at that place, right?
See, you can read it, right? If you see here, so if you can see, we do all amps join step from this table, and then which is joined to this table. Right? So through this you can see, check what is happening. Okay.
Okay.
Join is happening.
If lot of redistribution happens, means that will cause this. What is that?
Yeah, it depends actually. Yeah, if a small table is redistributed, then it should be good.
No, that's okay. If big table is distributed,
then it's a problem. Yeah.
Okay.
Then it's an issue, like it will take a lot of resource. In that case, we need to check like how to do.
There is a case called merge join product join is right. A product join, you call it as something like this is a Cartesian product, right? If 3 rows and 2 rows is there, 3 into 2, 6 rows, it will result by joining those two.
Correct, exactly. Yes.
So that will happen at the AMP level of distributing data.
Yeah, that will happen in the AMP level.
Okay.
Redistribution always happens in the AMP level, and if product join is more, like you can
that may not be related to our join condition, right? So that might be.
It may be related to join condition also. If you don't specify the correct join, then in that case the product join can happen.
Yeah, even if we given correct join also, if we are taking a chance of 2 big tables joining into a picture, so even though we have given the right joining condition, will that cause a product join?
Yeah, it may cause. So in that case, you need to check the joining columns, whether if you can create a secondary index on that, or you can collect stats on that, whether it has stats on those columns. And what is the value in those columns, like unique values or those kind of details you need to verify, and depending on the result we can modify it.
Okay, PJI stands for product join index. What is that?
Product join index. So this is the index which tells you how much product join is happening. So as per Teradata, whatever greater than 3 is not a good query. Okay. So you can have 100 PGA also, which means it's a very bad query, and you need to do something with the query. Means it actually consumes all the CPU and degrades the system. So either you have to abort it, tell the application team or users to retune it, okay? Or if you want, you have to retune it. We are responsible for the tuning. So that happens.
Okay. Say for example, if some query is running, if you want to increase the spool of the query, how we can do using viewpoint? No, you just
using
don't.
viewpoint, yeah, using viewpoint you can't do it. So if you want to increase the spool of the query, you need to modify the profile for that user. Okay, so
Oh, okay.
if you remember earlier, we give spool, temp, everything through a profile, right? Not
Correct,
directly
correct.
to the user.
Mm-hmm.
So if you want to modify the spool, you need to give the profile which is having higher spool space.
Okay, okay.
So that detail you can get it from dbc.profiles. It will show you which profile is having higher spool space.
Okay, okay.
Right.
Do you have idea about data labs?
Data labs, yeah. So we don't have data labs in this environment. So data labs is nothing but it's like virtual database. Okay, though it will be present under your system only. It will be considered as a separate database where you can create databases, tables, and then you can give access to the user. So even in production environment, users
Yeah,
can do the testings and all, and they can
correct.
import the
Yeah, we can
data
connect.
real time.
We can select access to the product tables and do their
Correct,
POCs, creating some samples
yes,
in the
yes.
data labs.
So yeah. So one thing in data lab is you can set the expiry date. So when you're setting up a data lab, you can give okay, this will expire in 90 days. So they should they may do the research in 90 days. So automatically all the data will be disabled. So if you want to extend also, you can do that. So it's basically a lab testing lab kind of things they
Okay,
brought it up.
if a new project or application request for data lab creation, in that case, who will do that? Teradata Corporation, or how we can do that?
No, usually DBS will do it. As we don't have it here, I can't show you.
Okay.
Might be I will
We'll,
check if I have any documents for that, right? I will share with you.
okay,
For
yeah.
data lab.
If anything, please send me.
Sure.
Okay.
So it's basically like granting the roles only. I think we'll create the roles and we can grant it like normally we do, right? So likewise we can do it. Or even the data lab has its own user setups. From there we can give the access.
Okay.
So I will search for the documents. If I have, I'll share you.
Okay. Okay. Fine. Yeah.
Anything else you want to see in the so this is the
no.
basic thing. The main thing is query monitor, through which we'll monitor the system. Okay, and then health check. I told, right? This health check portal. Okay, so with that you can see what is the current CPU utilization of overall system, what is the user CPU, how much is the system CPU, and then what is the AWTs. We can see here 35 AWTs are active now. So this is the major portlets you will be using for monitoring the system.
Okay. Yeah. What is the stats MGR? Stats manager.
Stats manager. Yeah. So with this you can automate the statistics. So you can create a job, and then you can automate the stats actually through this.
Okay.
So when you have the stats on a database automated, so system will read all the tables and it will decide whether stats has to be collected or not, and it will, as per the PE suggestion, it will collect or it won't collect. If the data has changed, it will check all those. If required, it will collect.
Okay.
So that's the stats manager.
Okay, fine then.
Okay.